Hello, I'm Anna Jordanis. I'm a lecturer in computing in the Medway campus of the University of Kent. Today I'll be addressing this question: can computers be creative? And what can we actually learn from looking at whether computers can be creative? Now, we know that computers are very, very good at mechanical tasks, processing lots of data, churning through calculations, doing repetitive tasks that don't require much in the way of input from anything that might be something like creativity. But recently we have been more accustomed to the idea of computers being able to do more intelligent things. We have, for example, quite a heavy reliance sometimes on our smartphones guiding us from A to B. I certainly relied on mine today to get myself to the Canterbury campus from the Medway campus. We're very, very happy with computers now showing us some kind of intelligent behaviour. We're accepting that. What we don't accept is the idea that computers could add something in that they're not being programmed to do. They could do something creative. If a computer is just a machine, how can it do these creative things? How can it be inspired? How can it work with new ideas? We think of creativity as something that's uniquely human, something that needs more than mechanical processing. But recently, one area of artificial intelligence has looked at exactly this question: can computers also be creative? So computational creativity is where we study the creativity of computers. We look at how creativity can be modelled or simulated or replicated in some way using computational means. So today I'll look at what this all means. I'll look at the question of why we might want to learn about computers being creative. And I'll think about what we actually learn from this work. There are various different types of computational creativity. There are systems out there, computer software out there, that have been written by researchers that can do all sorts of creative things. There are systems that can write stories. There are systems that can write plots for musicals and songs. There are systems that can improvise music. Systems that can do more creative things with science, such as scientific reasoning, where you have to think around what the right answer might be. There are systems that can paint pictures, or systems that can do visual things, such as putting the right colours together in a picture. And then there are systems that have been written which can do slightly more unusual things. There's a system written by a Mexican researcher, Rafael Perez, which can arrange furniture in a room in a creative way. There's a system which can generate a nice cocktail mix for you. What would work best? There are systems that can generate cooking recipes for you by being creative, not by following rules, but by being creative and coming up with new recipes, new cocktails, new furniture designs. They do this in different ways. Different systems work in different ways. It might be that a system has a bunch of rules programmed in it, and then it just is able to in some way select how it follows those rules. It might be that the system is told, okay, here's the rules, you can break this many of them. Or the system might be programmed in a slightly different way. It might be programmed to mimic the brain as closely as possible, or to mimic how we approach a task, what we do, what activities we do. And there's lots of different ways of being creative. And in computational creativity, we have a lot of fun working out how to make a computer do things like this. But it's not just about getting computers to do creative things for the fun of it. We also learn a lot along the way, and that's one of the major reasons why we do computational creativity. We're looking at using computers to help us understand our own creativity. But we come back to this horrible question: how on earth computers be creative? How can they be creative at all? That doesn't make sense. How is this possible? And actually, it's a really difficult question. But it's a really difficult question when you take out the computer. How creative is this musician? How creative is this artist? How creative is this computer system? This is a really difficult question for people to answer because we don't actually have a definition of creativity that we can use to answer this question. We don't have benchmarks. We don't have a very strong idea of what creativity actually is. It's a very subjective concept. It means different things to different people. Creativity is a different thing in different circumstances. And it's a problem when we're working in a computational field. When we're doing scientific research and we are trying to come up with a result and evaluate how well we've done, we need something to evaluate our systems against. But all we have at the moment is this subjective, crazy concept called creativity that no one seems to be able to define. So one thing that we do in computational creativity is to work out what it actually means to be creative. Now, I've tackled this question in a certain way, looking at the way in which we can define or understand what creativity is by looking at how creativity is talked about and what words do we use to describe creativity, to talk about creativity. The idea here is you shall know a word by the company that it keeps. If a word is often mentioned when you're talking about creativity, there's some connection there. There's some relation. That word is in some way related to creativity. The diagram here shows various words that very often appear in dictionary definitions of creativity. Now you see words here that a lot of them are not unexpected. New, originality, the ability, imaginative, ideas, produce. These are all words which give us a little bit more indication about what creativity means. So we can expand this, and using computers, we can expand this a lot. So what if we don't look at just dictionary definitions? We look at whole articles, whole writings about what creativity is. And we use computers to help us read through all these articles and see which words appear more often. Well, I did this, and I got over 600 words. So I narrowed them down slightly. I found that the words represented 14 different areas which are part of creativity, 14 different factors which in some way contribute to what creativity is. In the top corner there, variety, divergence, and experimentation, the ability to try out lots of different things, to go in different directions, to experiment with what we're doing. And we have, in the bottom left corner there, progression and development. So it's not just what you come up with first, it's how you develop it, how ideas progress as you go through creative processes. Some of these factors become more important than others, and some of them become more important than others in different domains. So for example, if we're working with a program that generates proofs, mathematical proofs of crazy concepts that people have been trying to prove for centuries, and a mathematical system is able to come up with the proof that people have been searching for, it will probably really need to come up with results. It will need to be able to generate results. It will need to be able to generate valuable results. If you're dealing with a system that can improvise music, quite often when people improvise music, the end result isn't necessarily the best. It's not the best that they could have come up with because they're just improvising. They are coming up with it on the spot, especially when you have students learning to improvise. But that's not the point, because improvisation as a creative activity still has value even if the end result isn't so good, because you see how they get to that end result. You see that what they do as they're improvising, the process that they employ to get to where they get to when they're improvising, is as important as the end result. I looked at this a little bit deeper. I spoke to a lot of musical improvisers. I said, for you, what does it mean to be creative when you're improvising music? What does it mean when you see other people improvising music? What is important for creativity? And 3 factors came out as the most important. This is very useful for me as a student improviser myself. I'm not the best musician in the world, but I know now that if I listen to what's going on around me and I interact socially and communicate with the people around me as I play, that's the number one thing that helps when you're trying to be creative when you improvise. Another thing which is important is domain competence, the ability to be good at your instrument, to know your scales, to know the way in which to play the instruments or to sing. And the third thing which came out as really important for being a creative musical improviser was the ability to become emotionally involved in what you're doing, the ability to show that you mean to do it, to show that you intended to do whatever you did. So if you just play things and it doesn't really work out and you don't really know what you're doing, that's seen as less creative. But if you show that you really intended to do what you did, that really helps to contribute to the overall creativity. So let's return to the idea of the computer improvising music. I wrote a system which is able to improvise music. It evolves its behaviour to become a better improviser as it learns from feedback. The system wasn't ever so successful. It evaluated against a couple of other systems quite poorly. It showed that it wasn't as creative as 2 other systems. My system was the little grey line that's at the bottom there, not doing so well. But what's happening here is that we evaluated these 3 systems that can improvise music, against the components that I showed you in the previous diagram. And then we weighted the results to say, these 3 at the end, social interaction and communication, domain competence, and intention and emotional involvement are the 3 most important. So let's make them larger than the others. So I know now, if I want to make my system more creative, I need to work on how the system interacts. I need to work on the ability of the system to use the musical scales and knowledge more efficiently and in more expressive ways. And somehow, I have this fascinating challenge ahead of me. How can I make the system appear to be emotionally involved with what it's doing? How can I make it seem to intend to do what it's doing? And if I can crack those 3 things, my system becomes more creative. So I'm learning how to make my system more creative, and I'm learning about what it means to be creative as a musical improviser. So let's return to our original question. Can computers be creative? Can they really be creative? Well, perhaps we will reach a stage where people are comfortable with accepting that computers are genuinely being creative in their own right, just as we're learning to accept that computers can do intelligent things for us. Perhaps we won't get to that stage. One thing we do have to remember is that we're in the very early stages of doing this. We've been working with the creativity of computers for a relatively short amount of time, especially compared to how long people have been around learning how to be creative. So it's almost like you have a small child in their first steps learning how to do things there. It's like when your child brings back their painting from the nursery and you don't say, oh, that's not what Picasso would have done. You say, oh, wow, that's wonderful, because you're encouraging them to develop their creativity. And in the same way, it's quite helpful to think of computers in this way. They're the small child learning to develop their creativity, and we're learning how to help them become more creative. So it unlocks all sorts of creative possibilities if we can just harness this idea of computational creativity. But even if people never understand the idea of computers being creative, if they just can't accept this, still we have this amazing way of studying our own creativity through that of modelling it in a computer system. We can try out all sorts of ideas in computer systems that we could never try out on people and see if they help us to develop the creativity of the computer system. And in that way we learn about ourselves. So with computational creativity, there's a huge amount of potential to learn about our own creativity. Thanks for listening.